All right, ladies and gentlemen, it's showtime. This is the event you've all been waiting for over 3 years. Actually, we've been waiting for it for over 3 years, and we're really glad that you're here. So my name's Ken Russell.
Kelsey Gilbert from Mozilla and Google.
Oh yes, right, from our respective companies, and we will be your hosts. Thank you to Lisi from Kronos and Jeff also from Kronos for the organization, for arranging everything. And thank you so much to the event staff, the caterers. You guys are awesome. We couldn't have done this. We're so happy because during COVID, all the event spaces in San Francisco shut down. So this was the option, and you've just made it an awesome one. So let's dive right in. We don't have a lot of time, so I'm going to breeze through these slides. They're already online, so you can look at them offline. Come a bit closer. Don't worry about the occlusion, I think. All right, so let's jump right in. So as we say at all of our meetups, please join the online communities for both WebGL and WebGPU. We've got a really vibrant community, positive energy going on, and you all are, implicitly part of it. Tell your friends, have them join, and if you're building stuff for the web, please do share it. So all these links go to actual websites where you can see and join the communities. There's one for WebGL, there's one for WebGPU, and there's a lot of cool stuff showing up on Twitter for both APIs. So some quick general WebGL updates. Browsers are continuing to maintain and enhance their WebGL implementations. This cycle since the last meetup, we got some smaller fixes to conformance tests and some draft extensions, various fixes for partners, including Google Meet. They're doing background blur with WebGL right now. It's very exciting. We implemented GPU timer queries in Chromium and WebKit with the Angle Metal backend, so that's out there and you can use it. Alexei Knyazev, who is independent but affiliated with Kronos, has been doing some awesome work, pouring through all the GLES extensions, seeing which ones would be the biggest bang for the buck. We've got a quite long list here that would be relatively little effort to implement, but bring really good developer functionality. So we're looking into these. Your feedback is welcome. If you have like a native app and you were struggling to bring it with full fidelity to the web, we want to know that and focus on those. Alexei has developed a draft version of clip cull distance, and if you have been doing a lot of different like 2D and 3D rendering algorithms, this is a really fast way to cull geometry that's outside the view volume, and it speeds things up a lot. So please try this out. It's actually in draft form right now in WebKit and Chromium. And so if you try it and you can see like a big speed up of your draft, we'd love to know that. It's more motivation for us to push it over the finish line and get it into community approved status. Same thing for depth bias clamp. This cleans up artifacts at the ranges of view volumes where like your shadow volume is really steep and the offset that you do from your geometry is too much and the shadow disappears. So this fixes this problem. Alexei implemented this all the way through all the stacks again. And please try it out. It's in draft form right now in WebKit, and it's coming in Chromium. So again, please try and see how much it improves the shadows in your 3D scenes. A really exciting development. Today, Chris Dalton from Rive is here somewhere in the audience. There he is, hiding in the back. And he's been working on a pixel local storage extension. Thank you, Chris. Figuring out how to abstract over this concept that you're going to have like a little bit of storage per pixel that you can sort of write to and read from during separate fragment shader invocations. You can do a lot of cool stuff with this, including custom blending. So it obviates the need for blend equation advanced coherent, which was a proposal for like 3 years, and we didn't do it because it's got too many driver bugs. But Chris has a demo checked into the repo right now that does all of those blend equations using pixel local storage. So you can now do this at the user level. It's very, very exciting, and he's going to demo it later. Thank you. So that's where we stand on that. And a major area of focus in Chromium right now is still Angles Metal backend on Mac. So WebKit's already shipping it, Safari's already shipping this, and we intend to ship it in Chromium as soon as it's up to parity with the GL backend. And in Chrome, we use this for all the rendering, not just WebGL. So it's really got to be at the same level of performance and memory consumption. So still a few remaining blockers. We have workarounds for 2 out of the 3, and the third one is being worked on. So hopefully this is the last round of iteration here, and we'll turn it on by default as soon as possible. And with that, Kelsey will walk you through what's new in WebGPU.
Sweet. Thanks, Ken. WebGPU. I'm one of the co-chairs for the working group, so that's why I'm here presenting this. And diving right in, you probably already have heard of this. It's our next-gen API for the web. It's a successor to WebGL. You're still going to have WebGL. You're still going to have WebGL 2. They're still around. We're still developing them. Like Ken got into, we still have investment in the area. WebGPU is just the new thing that's coming, particularly later this year. More news on that later. The big ticket items are lower overhead and like compute shaders and a bunch of other stuff we're hoping to get to eventually. Ray tracing, we know you want it. We know you want it. We'll get there. Standardization updates. So we're so close to version 1.0 from a standard standpoint. And I know we've said that for a while, but now we're actually really, really close. We had a face-to-face meeting in February, which is also our first face-to-face meeting in a while. So super exciting for us. But while there, we got consensus on all the remaining outstanding API and WGL issues. So that's like all of us browser companies getting in a room and figuring out the problems with all the things that we identified as actually blocking us from releasing. So we actually have consensus on all of those. So we're making serious progress there. And now we finished our implementations. More details in the links on the slide, but I'll just skip ahead for now. Implementation status in Firefox, there's a pref. You can turn the pref on. Probably like it's for experimentation, not for just like turn it on and browse the web. We're getting there shortly, like very, very shortly. And then like actual release later this year. Super excited about that. Stay tuned. Chromium is releasing their first version in Chromium 1.13 in May. So it's like the train is on the tracks. It is leaving the station. It is going out. It's incredibly exciting and like big props to that team. Windows, Chrome OS, Mac, Linux, and Android are coming later. And this is tracking the top of tree specifications. So this is super, 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 super exciting. WebGPU you can also use outside of the browser. If you ever think like, man, I wish I could do this outside the browser, you kind of can. Here's 2 ways to do it. Deno is one of them, though heads up, they're actually disabling WebGPU for now while they resolve a startup time overhead issue, but we're working on it, so don't worry about it. And Node.js is also another way to do it. Those are both exciting and will either be very useful for you or not useful. Partnerships and collaborations, we have a lot of links here, a lot of names, 3JS, Babylon.js, TensorFlow. At the bottom, we'll note we have fantastic feedback from and collaboration with Unity. Exciting news later in the presentation. I'll just call that out to dangle that in front of you.
And by the way, you have to stay till the end because they're the last presenter. So you're not going to get to see the cool stuff unless you stay till the end.
We have resources. This is our resources slide. There's a bunch of great resources here. One thing that I do want to call attention to is Austin's WebGPU samples were previously in his own repo. We've now moved them into the github.com/webgpu.org. So they have new URLs, both for contributions, like patches welcome, and also for like just running them. So check it out. And contributing, give us feedback. We're still looking for feedback. Yeah, we're wrapping up V1, but like we're not done yet, right? Like these are our initial releases. There's a bunch of things on deck for like versions after 1. So like still want feedback. So please keep giving it to us. We're very open to it. We really, really want it. Like we would rather have you come to us and give us feedback and like realize that like we've heard this feedback before. We would rather have that than to risk not having your feedback. So like default to tell us instead of assuming someone else did, because a lot of times no one else has. That's it. That's my slides.
Thank you, Kelsey. All right, we got a lot of awesome presentations for you tonight. So Rafe Levian from Google will be showing you some awesome GPU path rasterization on the web using WebGPU. I'm going to disconnect here. And please welcome.
Thanks, everybody. Should I use this microphone? Okay, great. All right, let me get everything going. Yeah, might as well. All right, there's the screen. So So I'm going to mostly be going into the demo. I just have a few slides to sort of introduce the project and sort of give you an idea of what you're actually going to be seeing tonight. So Vello is a project I've been working on actually for several years. It used to be called GPU, but we renamed it for a bunch of reasons. It is a 2D graphics rendering engine for modern GPU. So it's a real bet on compute shaders. Architecturally, it's a pipeline of compute shaders. And the idea of it is that you, on the CPU side, you upload an efficient binary representation of vector graphics. So it's sort of like SVG minus the XML cinematic universe and plus binary. And so you get that uploaded, do very minimal amount of work on the CPU, and the rest of it just happens on the GPU. So it's all implemented in WebGPU, and the shaders are written in Wigzel. And we have really ambitious performance goals. And one of the other goals is because all that work is happening on the GPU and not the CPU, the performance scales with the GPU power. So you get just amazing results on high-end GPUs. So the imaging model that it supports is kind of all the usual 2D things. Paths, we have fills and strokes, we have different kinds of gradients, it does clipping, it does the blend modes, all the exclusions, you'll see those. Images, text with glyph runs. Currently, it's rendering all the text just as vector paths, but we're going to have a cache for that to give you more performance. So that's the introduction. I really want to go kind of straight to the demo here. So I'm going to start. Well, let's start with this one. So this is a test scene that we have in our suite. This is kind of a standard test scene that you see of 2D renderers. So this is a map of Paris, and you can see it zooming, and we have like rotation. It's all happening, all being rendered dynamically here. And it's 60 frames a second. I'm kind of disappointed. I was like hoping that they would be able to hook us up with a 120 frame a second. But I'll just turn VSync on. So it's actually attaining, turn VSync off. So now it's rendering at 120 frames a second, and you're just not seeing it on this monitor. So that's a hint of like what performance this render is capable of. It's fully dynamically rendering this at on the GPU at 120 frames a second. So I'm going to also run through some of the test scenes that we have in our suite. This is all open source. You can go to the repo. There'll be links. The links are in the slides. And so this is just showing off different aspects. So this is really showing off mostly the strokes. This is, this combination of a bunch of stuff. Actually, this one is interesting. It's we added images only in the last couple of weeks. But the other thing that you're seeing is that there's text that's being rendered here that's from a variable font. And the parameters of that font, the width and the weight of that font are being animated in real time. So all this text is coming from a variable font and being rendered completely dynamically. You're seeing there's other things like the even odd, these are tech images, the even odd winding numbers and the blend groups with the alpha blending, that's all in there. This is showing some of the gradient stuff and the fact that we can apply like different transforms. Like if I do rotation, that's independent of the rotation being applied to the scene is independent of the rotation on the individual gradients. This is showing you your blend modes, all of your exclusions and, chrominances and luminances. So it's doing all of that. By the way, no limit to the amount of nesting of how deeply nested those blend groups are. These are technical images, conflation artifacts. Let's see, what was the last thing? So that's just a run through of that. Then I want to show you some of the animation player stuff that we have. So we do, this is a, let me see. I'm holding the mic, so it's a little awkward too. All right, let me see if I can find this. Use the, okay, yep, here we,
Just move it closer.
Yep, here we go. All right, this will be better. We'll get to there. Short answer, yes. All right, so there's a fun little animation that's playing, and actually I don't have the VSync on this. This is a separate binary, but I'll show you this. that's 256 instances of that animation. As you can see, they're all like different offsets. So this is all, none of this is being pre-processed and pre-rendered. This is all being rendered completely dynamically. And I have a bunch of these, and it's all kind of the same story, that you can have lots and lots of instances, and it will actually, in some of the cases, the frame rate drops. If you have 256 instances of one of these more complex ones with more overdraw, the frame rate will go down to like 80 frames a second. So we're still working on the performance. There's still more to do. So somebody asked about whether it will run in a web browser. Well, guess what? So this is Chrome Canary. The little, I don't know why, there's usually a pop-up that says you're in a dangerous thing because you've turned on WebGPU and that might affect your stability. But in this case, it's running, you'll see it's running the exact same. I mean, this is exactly the same code. This is all, this is all the same stuff. And this is running, the images, like all the variable text, all this stuff is running. And this URL that you see there, if you have a Chrome Canary browser and you just type in that URL, then you can play with this yourself. So let me go back to the slides, and there are resources. Let's see. Yep, that shows what we did. And so these are all links. This is all open source code. It's developed in the open. There is a significant open source community around this. It's not just me. It is written in Rust. It's using WGPU as the backend. So all the native stuff that you saw is running. So that will run on Metal, Vulkan, DX12. And also, if you come to me afterwards, I'll show it to you running on Android hardware as well. So the WebGPU demo is there. There's the link. And if you're interested in getting involved, like if you want to become part of our open source community, the best place to enter that is through our discussion forum, which is a Zulip instance. We're very grateful to Zulip for hosting that for us. And there's a GPU stream, which is where all of the Vello stuff happens. So I know we have a full schedule. I'd love to talk all night. Come see me afterward, and let's go to the next presenter.
Awesome, Rafe. Thank you so much. Okay, so next up is Jean-Marc Ham from Vectary. I'm in the way.
No, all good.
And he's going to show you some no-code WebGL development solutions, I assume?
Something like that.
Something like that. Okay.
Something like that. Just give me just a sec, please.
While we're plugging in, I'll mention, please hold Q&A till the end. We should have some time. And folks that are watching in the live stream, please feel free to type in your questions there. And we're monitoring the doc, and we will answer those later. So please participate.
All right. Okay, so can you hear me well? All right, so I come from Vectary, and back in 2017, something like that, I basically decided to quit my job with my wife, like go traveling, do some soul searching, and all those things. And then after a while, you realize, okay, like maybe it's time to do something with your life. So you go back to getting a job. And, like for 3 months, you're going through all that stuff again, like after all the mindfulness the travel provides. And you end up in your in-laws' house back in Slovakia. And yeah, it's great, like next to border in Poland in the mountains. And that's basically why I came to be part of Vectary, which is a small startup based in Slovakia. And basically we have been like for 8 years now running from 2016. I joined about 4 years ago, and we basically started as a mesh editing tool. But since then, like many different people have come to us, and we've basically become a platform now. And yeah, as you can see here in the slide, basically more than 5,000 schools are using us basically just to onboard young people into using or start using or getting into 3D, like on the web. Everything is on the web and running for the web. So I would like to talk, the boring stuff, business. So, mainly for us, like we started as okay, let's put everything for free. But, after 8 years, investors are like, okay, hello. So yeah, we definitely need to talk a bit about business and what we do there in that space. But I would like to just keep it in a sense that what we're trying to do mostly is get the message out there, like, hey, there's something else apart from consoles and something like 3D that is actually happening on the web. So to get those students to actually like get interested in, like, this is running on my class on the browser, I don't need to install anything, like how do you do that, and basically sparkle a little bit of that younger engineer that maybe like one day is going to be sitting like you guys. So that's basically what we try to do. So just these are some some points like for information, like how do we actually are using things on our tech stack. And from there, we've come to become just like I said, like more than a platform. And basically right now, like we're at the point where we really think that like we are ready to compete, like for example, like in rendering terms with for example Sketchfab or other platforms. So here I'm going to be showing not live demos, because 10-minute presentation, you don't want to bleep it up, so in here you can see in this orange can, like there's like basically like K-frame timeline animations, reflective bubbles, baked ambient occlusion, light maps. There's a bunch of stuff going on. For example, here you have a turbine with 1.5 million polygons rotating on real time with reflections, SSR. There's also like analysis that you can run on your preview to see, for example, like what or how can you improve performance, because basically we want this to run like anywhere, like in any mobile phone and so on. So you need to be able to do a little bit of tweaking. Like so for example, here we have like stickers that like directly unwrap on any geometry. Here we are using animated textures. For example, you can use Lottie files to add into the normal maps, for example, to create this rippling water effect. Or you can use GIFs as well as you want, like for example, like how the watch is animating, and like all pretty cool stuff. So next one, for example, like we have here also in these advanced materials, we basically are able to, like we want to be following a little bit the current standards that, like 3JS is using with the maps and so on. So, and also we're trying as well, like to not go too far away from the Chronos standards, for example. So we have a PBR system that allows us to, like mostly get the effect out there, like more or less that you can see as well, like any pipeline that you would find in, like in any other 3D software. But we try to, like onboard and see like in people like that are not really related to the 3D space. So we try to appeal a bit more to the audience. And yeah, for example, here you're seeing things like depth of field for the cameras, composition of the scenes. Like for example, like in this watch, like there are like the animations, there are hotspots that are triggering different things, like this custom Lottie file just like running there. And so at this point, like we are at like a stage, like we are trying to implement all of the stuff, like I was mentioning maybe before, like here, for example, like refraction, subsurface scattering, thin film, clear coat, and all those things. like dispersion work in progress. And basically, yeah, we have one-click unwrap generation of light maps. I can, and then to complement all these, and let's say, okay, how can then like come to a point where people can use this in an actual way without coding? Because yeah, like as maybe you are interested in like 3D stuff like in the browser, but you don't really want to or know how to code. No, it doesn't like anybody. Like not everyone is like wants to go through Bruno Simon's course like on how to do like start coding on the web. So so that's why we also have no code interactions that we are just like really trying to get out there. And you know, please, like if you have like any time to go and check it, you know, right now like this is like for us like more on the pro side. So you know, like to go and check this stuff, like probably you will need a subscription. Like again, sorry, you need to pay the bills. But it's pretty cool. It's pretty cool stuff, like nonetheless. But anyway, like here, you, for example, like you were some of the things that we have been working on is like just like getting those conditional logics like that, and we are working slowly into getting an API that, like, you know, in case somebody would need it, they could use it. Like for example, I don't know, to hook up like weather services, so you can then, you know, like do your 3D graphs being fed directly. You create your scene here with your 3D graph, and then you directly connect it with an API and so on. But that's still on the work. So we try to be, again, first and foremost, no code, and just like to tap into that audience that doesn't know, like, okay, like how should I implement, you know, like any sort of effect, like in terms of again, like reflections, SSR, and so on. And it should be basically just you know, like at the point where like the product for us, it's really important that we iterate a lot. We have features in development for like maybe a year that then we don't publish because they are not usable for the public. For example, last ones I remember, like where sorry, for me right now it's like 3:30 in the morning. So so basically, yeah, like there were some features that again, like they're not there yet. So like we don't try to publish them because like they need to be like directly usable. We will add like some of those things on the slides as well, so people can just like check it out about these new things that we're not developing, but I cannot remember right now. And then like the last thing is that really important for us, that people need to be able to collaborate, to just like come together and see, okay, like we need to get teams on like onboarded of people that, you know, like need to try to get like all those developers, artists, marketers, and everything like in one single place where they can basically comment, share, and everything like just in one single link, and just can just put it anywhere, like Notion or like Mote or whatever it is that your tool you're using. We have implemented like all the APIs, like I showed before, like there are like 15 APIs that we have implemented, like to actually, for example, you know, tap into the OAuth protocol. So, you know, like you can just like copy paste and there you go. You have 3D on your website or on your document or like on your presentation, like, and so on. So yeah, like that's it. Basically, that's my time. So thank you guys for being here, and yeah, let's do something together. Like hook me up an email anytime, anything you want. So later on, like yeah, questions again. Thank you.
Awesome stuff, Jaume. Thank you so much for coming all the way from Slovakia to show us your awesome product. This is very exciting stuff. Collaborative, fully featured 3D on the web. This is what it's about. This is why we're here for the WebGL and WebGPU meetup. Next up is Andy Ray, and he's going to show some GLSL shader editing with a hybrid graph. And I hope that this is running in a browser because there was a lot of GLSL, and I hope that it's WebGL, but we'll see.
I am running in a browser.
Yes.
I'm definitely not intimidated by being in the same room as the people who built the technology that I built my thing on. So I hope all my jokes land. So excuse my nerves also during this presentation. All right. So, hey, my name is Andy. I built a tool called ShaderFrog a while ago, and basically for the last few years, I've been iterating on the next version of this thing. And that's what I want to talk about today. So they say not to do it live, but I'm about to go do the entire thing live. So bear with me. Yeah. All right, let me get in the right state here. So the concept that I want you to keep in the back of your head during this whole thing, nope, that's the wrong one, is this idea called the hybrid graph. And you're going to see what I mean by the hybrid graph as we go through this. Can y'all hear me okay? I don't know if I'm too close to the mic or not. Okay, cool. So the first thing that I'm going to do, so I'm in a graph editor, and I'm using Three.js as the engine right now, but this is not a Three.js editor per se. This is the GLSL editor. So also hold that idea in the back of your head too. So I'm in a graph editor with sort of a blank template here. And the first thing that I'm going to do is I'm going to go add a node to this graph. I'm going to plug it in. I'm going to go double click on it. There's nothing super magical here. I'm going to go add a random shader source code. The GLSL here, the source code doesn't really matter. I'm taking in some an image and some UVs. I'm warping the UVs. I'm dropping the blue channel, whatever. Great. Oh, I got to go save the thing. I'm going to go save it. And then let me plug in an image so you can actually see what it's doing. All right. So this is nothing special, but the first thing that I want you to notice is this source code node. The tool found the inputs and outputs to the program automatically. So you can see that it marked the uniforms as inputs and it marked the main function as an output. So that's sort of the background of the hybrid graph. Okay, so to sort of show you what this thing can do, I'm going to add a new sort of stock shader to the graph here. I think this one came from Shader Toy. I'm not really good at writing shaders, which is the funny part of this whole thing. So I just want to show you what this one does. It's just a procedural shader that generates some circles. Looks pretty cool. I'm going to plug back in this one. So the first neat thing this demo can do is that you can actually take a shader and use it as an input to any other shader. So I'm going to do that. I'm going to plug in the circles into this code node down here. And you can see two things happened. We're still preserving the UV transforms and the original shader, and we're dropping the blue channel as well. So if you look at this graph, like this effect is really just two nodes here, and that's some of the power that you can start to envision. And the blue nodes or data nodes is a little verbose. It is a demo. All right, and then, so I told you that we're in Three.js as the engine, but you can sort of see here, we're not really using any of Three.js's actual engine information. Like we're not using their lighting, their vertex animation, all that cool stuff. So let's fix that. I'm going to go add in a Three.js physical shader. And then I'm going to go plug this one in. And then you can see, so this is their PBR material. They call it a mesh physical material. And now we're back in Three.js land in the full engine. And so remember, what I told you is that you can use a shader as an input to any other shader. So I'm going to take that first shader that we wrote, and I'm going to plug it into the texture map of this shader. And now I'll turn on the lighting helper so you can see it. We're actually getting full Three.js lighting information on your shader. So let me tell the story from one more perspective before we move on. Is if you're a shader author, you just want to write your own effect independently, you could do that in this tool, treat it as a node, and then you can plug it into the engine shader in the end and start to preview this in the engine. Okay, so we've only been talking about vertex shader, or sorry, fragment shaders right now. So you can imagine this is kind of easy because a fragment shader outputs a color, and you can add colors together. That's great. A vertex shader is different because it maps the thing to screen space in the end, but this tool actually works for vertex shaders as well. So let me open this example. Wait a second to load. It's the crowd pleaser one. So what's happening here is there's a procedural fireball shader that I'm plugging into a Three.js physical material and taking advantage of Three.js's transparency, all that good stuff. But what I want to show you here is if I bypass the Three.js shader and just plug these things right into the output nodes, this is the raw shader. So this thing is being automatically composed with the 3JS shader in the end. So as a shader author, I can go make this thing and then reuse it in my engine, hopefully without having to write any additional code on that. Okay, I want to show you one more example over here, which is, let me load this one. I told you we can, really this tool actually lets you plug the output of a shader into any part of any other shader. So in this case, I'm taking a shader and I'm using it as the normal map instead of the texture map. And you can do this arbitrarily with any part. This is one of the cool demos. So if I take the actual normal map shader and I plug it in here in the end, you can see this is the procedural image that we're using. And I'm going to go plug it back into this node and rewire things up. So there's two things I want to call it in this graph. If I go double click on this normal map node, this is just a program. It's just taking an image and it's just doing whatever, it's mapping it to normal map color space. So if I go back to the graph, like you don't need to wait for me to create a normal map node for you. You can just write one if you want to do the transformation. And then if I zoom out a little bit, like if you just look at the green nodes, this is four nodes to make this effect. All right. And then the last thing, the home stretch is, so we're in 3JS, but I told you this is not a 3JS editor. This is a GLSL editor, and 3JS is implemented as a plugin to this system. So I'm zoomed in, so the text is a little garbled, but I'm going to switch the engine from 3 to Babylon. And obviously this can't work because Babylon doesn't have a 3.mesh physical material, but who cares? Let's do it anyway. Dramatic pause because it has to compile everything again. So you'll have to trust me. This is running in Babylon and not 3JS. The graph is it's almost entirely the same. So in fairness, that was an offline transformation that didn't happen live in the browser. But so what we had to do was we have to say, we have to define a mapping between 3JS's shaderland and Babylon shaderland. So 3JS has a mesh physical material, Babylon has a PBR material. And if you can define that mapping, you can do that at the material space. If you can also define the GLSL transformations, that's the more interesting part to me, you can, in theory, map one shader from one engine to another at the source code level. This does some of that, but there's also a lot of challenges that come along with that. So that's not really the part of the demo. The important takeaway from what I just showed you is that this same algorithm is working for multiple engines. And so Babylon's also a plugin, and then maybe introduce your plugin here later at some point, depending on if this thing takes off. All right, that was it. I'm going to jump back to the slides for a second. By the way, I meant to start off this talk with, I think this is a novel shader editing concept. If it's not, please let me know. Come find me afterwards. And then this whole thing, I had to build a compiler for this thing to work. So there's an open source compiler, which is already getting some traction written in JavaScript. I'm pretty happy that people are using that thing alone. My claim to fame is that when I was writing this, I found a bug in Angle, which got fixed recently. And I also found a typo in the Kronos grammar spec, which also got fixed. Yeah. So the spec was great. It's not dunking on the spec. Cool. And that's it. There's links in the slides which are online. Thank you all.
All right. This is just awesome stuff. Thank you, Andy, for coming and presenting. Huabin, please come up. I wish that we could use that when we're developing shaders in the browser, but unfortunately, there's a bit of a compatibility meta-circularity issue. Maybe if we rewrite the browser in JavaScript, we can start to use this. All right, next year. So now up is Huabin Ling from Cocos. They develop is it appropriate to say a game engine or just a
game engine? It's just a game engine.
Okay, so yeah, a game engine that's got a lot of cool features, and they're coming to WebGPU, and he's going to show us all the latest stuff. So thank you for coming, and please.
Thank you, Ken. And it's working. Okay. So I'm just gonna try to be quick, keep it in 10 minutes because I also want to go to the restroom. Yeah. And I will go straight forward to the demos. That's the most recent demo that we built for the web. Also for native, it's a cross-platform engine, so it supports Windows, Mac, iOS, Android, web, instant games, and also Nintendo Switch. This demo, I think we also got video, audio. But I muted this. Why it's so? The resolution is not right. Sorry, just a moment. I lost connection?
Turned off and on.
Serious. Yeah, just wait.
Okay. Yeah, I think that might happen when I go full screen. Okay, that seems more accurate. So this is using deferred run pipeline on web. It supports both mobile web and desktop web because we are focusing more on mobile than desktop. That's our positioning. And so also that means the Cocos go 3D now, because a lot of you, especially when I go to America, recognize Cocos as the old Cocos 2D and Cocos 2D X engine, but now it's totally different. Our mainstream product is Cocos Creator. I'll wait it to let it load. And let's go to my PowerPoint so that we can see more. That's the editor. So it's full 3D editor. It's also support our 2D game engine, and it can be developed and debugged on web platform directly. And we support publish to iOS, Android, all these platforms, and we generate exactly the same result. So it's the cross-platform part, maybe the main strength of our engine. And this is our WebGPU support. It was an experimental feature in 3.6. Now we are in 3.7. But actually, when Chrome wants to go with pure WGSL, it was broken. So we are putting it off. But we are trying to figure out which tool to use to compile our shader to WGSL. So we are investigating Naga and Tint. The problem for us is that we use a lot of Uber shader. We don't want our user to modify a lot or provide a lot of shader. So that's we must compile our shader on the fly in runtime. That's also causing problem because either Tint and Naga, if we compile it to WebAssembly, it will be very heavy. And we are searching for solutions, and we are trying to get around it. That's because I'm switching to another screen, so it's paused. Yeah. So I will show you another example first. It goes offline. I preloaded everything. Okay, this one works. So this is a small Cocos on the screen with reflection. It's a reflection demo. It's also using deferred pipeline, and we have a bunch of settings here. If you see the pipeline, there is shadow stage, shadow blur, gbuffer, SSL, and bloom, light shaft, TAA, FSR. Why it doesn't work? So live demo has this kind of problem. Yeah, that's a real game. Top War, they are building their game using Cocos Creator, and they are publishing to both Android, iOS, and web. So they are also buying traffic directly from YouTube and Google search. I think I really lost connection. So finger crossed, hope this works. And another example is Ubisoft Nano. It's multiplayer games running on the browser, running in the browser on Pocky. We have Pocky friends here, and also on other platforms, game distribution, etc. I don't think I can show you everything, but I can show you some videos. This is not cool. This one is cool. This is we can say metaverse example made by Media True Space, and it's a Chinese manufacturing company, and they are investing a lot in the in tech, I can say, in metaverse maybe, and they are creating this space to showing off their it's for a meeting actually. It's for offline meeting, and they are creating this space for people to knowing their technology, knowing what they are doing, understanding better. It's very cool. It has a lot of cool features like a reflection probe, lighting probe, and a lot of gameplay, cool gameplays. And this is awesome. This is Discord put party. Discord is using our game engine to create all of their games, and it's launching. I think there are two. Is launched. Put party is the first one. It's for multiplayer because they are a community. So in every server you can activate the game feature, and you can play with others in a channel for the game. And it recently get published on mobile. So no matter on desktop or on mobile, they are using web technology to create that experience. And the last one is really exciting because I'm not sure how many people can understand the value here. As you can see, the most left part is WeChat. This is WeChat app, and inside WeChat app, there's Chinese New Year. It was a Rabbit Year, and if you tap Happy Rabbit Year, it will give you this effect. And this is running in a browser, in a web view. And they are using it because they are using our engine to create this effect. They have previously using other engine, but when they replaced to Cocos, the loading time on a low-end device, the loading time reduced from 4 seconds to 300 milliseconds. And thank you. And then it reaches much more people, because before, if the effect get loaded in such a long time, they will cancel it. You can't show that because people will think it's strange. And with Cocos, a lot of people really for the first time see all the effects, special effects. They have launched the special effects like for 3 years, and this is the first time a lot of people see it. And the right side editor was the editor view. I'm still gonna show you the game, our most recent demo. I hope it can load this time. Okay, maybe you can type the address here: preview.cocos.com/cyberpunk. I will type it here. Preview.cocos.com cyberpunk. Okay, the lake demo unfortunately doesn't work, and this link doesn't work very well on iOS currently. But we are fixing the issue for the next version. It's because our uniform is exceeded on iOS. It declares that they have so many uniform, but they don't, and our main role doesn't show up, but the rest of the thing can work. Okay, I think I can go right here. Yeah. Oh, I can maybe show the video of the at least I have the video. So this is Cyberpunk demo. We use Cyberpunk style because there are a lot of lights, and it can show how default renderer can look on the web. It also uses our latest render graph render pipeline, and it's a cross backend, Vulkan, Metal, and GLES WebGL backend. It can help users build a customized pipeline very easily. It's very, very powerful, but it's just beginning to show its power. That's in our editor, and we can see the reflection probe. We can see the fogs. No, it's not fog. It's a smoke effect, and we can see the whole thing. Okay, that's all for me. Thank you. Thank you.
Thank you so much, Huabin, for coming all this way and showing us this stuff. Okay, so first of all, the graphics technology is amazing, and second of all, the reach is amazing. WeChat has a ton of users, and so if web technology is being used to build those effects, that's really something else. So next up, we have a remote presenter, Thomas Lucchini from Microsoft, who's going to be telling us about the latest advancements in Babylon.js. So Thomas, are you on?
Yes, I'm on. Can you hear me?
We can hear you.
Awesome. So let me share the presentation here. And here we go.
I'm really late, but they would need me to get a badge.
All right. Can you see the presentation?
Yeah, suffer me.
You can? Okay. All right. So hello, everybody. I'm Thomas Lucchini. I'm the PM of the Babylon.js team at Microsoft. And today we're going to talk about Babylon 6. So that's our upcoming version that is coming in a few weeks on April 20th. For those who've been following us, last year was a huge release with a lot of features, a lot of tools. Well, we had two, was Babylon 5, right? So it was kind of a must for us. For this release, 6.0, we've been taking a different angle and looking at some kind of improvements, enhancements we can do to a lot of existing things within our framework. Of course, there are still a few new tools and some cool feature, and I'm gonna show a selection in the next few slides. So let's start with what we call performance priority mode. And maybe let me give a little bit of background. What's very important for the developer of the team is to maintain backward compatibility and also try to ensure as much as possible simplicity for the other developer that develop with the framework, right? So that's kind of like some of our two key pillars. It's important to make it easy for us to have quick and nice applications. It's important for us to make sure that although it's painful sometimes to ensure the backward compatibility when we release an API, it's forever, right? It's painful because it takes a lot of energy also to make sure it will always be maintained, always be there. But as developers, we know how important it is, right? That once you write your code, you know it's going to work forever, right? So with a upcoming version of Babylon. So that's a key work on the team. And it will always be here. However, we notice that in some cases, and we're talking about edge cases here, some developers want to go beyond this, want to do more themselves. So it's a little bit more complex. There is less things that are done by the framework. And they may also be okay to lose some backward compatibility with trade-off being getting more performance, even more performance. So that's why we introduced two additional mode, what we call intermediate. So for instance, there, the scene will automatically freeze materials. So you have to yourself unfreeze, make the changes and refreeze the scene. In aggressive mode, the scene will skip all the frustum clipping phase altogether. So you have to manage more things yourself. But you can get, as you can see on the screen here, up to, I think in this example, it's 64% performance. So it can go faster in some cases. Demos is available, and documentation is there. So if you go and check the slides, you'll have all the details for those modes. Another thing, which is this one is new, is fluid rendering. So there is now a new fluid rendering component that we've added to the scene class, and it allows you to render particles as fluid. It's based the implementation is based on a classic paper by Simon Green from NVIDIA, and it's basically using particles and the position of particles have to be provided, because here we're talking about rendering. We're not about rendering fluid. We're not talking about the simulation, right? So you have to do your own simulation and then basically pass the particle positions to the component. But that's allows you to see some nice effect there. There is plenty of examples there in the links. You know, this is water, but you know there is wine too, although it doesn't change much. This feature, screen space reflection, is an example of enhancements. It's already it was already there before, but it was implemented as a post process. So there was some limitations. So we, Alex in the team, rebuilt it using with the render pipeline, and then you see the effect here on the demo. It looks nice, right? So this reflection effect on the road. Like imagine that would be like the perfect still water. And the way it works, for those who don't know, it's basically reusing the scene that has been rendered, right? And reusing this in the reflection too. So there are some limitations. Like if you look under the car, we should see what's under the car, right? With a real reflection. In this case, we don't, because it's just reusing what has been rendered, for instance. But everything can be done, and it works with WebGL and with WebGL 2 and WebGPU. We'll see at the end that you know, engine we try to maintain backward compatibility also between WebGL and WebGPU for the application that use Babylon.js. Completely different topic. We're talking here about accessibility. I think most of you know that you know, it's WebGL is not really visible, right, by a screen reader. The whole canvas is not really visible. So what we did here, it's Sunny from the SharePoint team that built this, you know, did this contribution to the framework. And what she did is basically creating HTML twin elements for objects in the scene. So once you install a package, you can, in your code, on some nodes, the nodes you want to be accessible. You don't want to show everything, right? It's going to be overwhelming. But what do you want to make visible by the screen reader? You basically can tag and add the text that should be read. So that's for describing the scene, what's on the screen, what is important on the screen. And there's also interactivity that is important. Of course, it can be with the mouse, right? So you can navigate, you can implement some navigation using the keyboard. That will automatically be done by the action manager, and that will translate the twin elements changes, if any. So some good example here also on the links. Talking about GLTF, of course, we're going to talk about WebGL and WebGPU. We're talking about GLTF, who's been here, I think, since the beginning, before even I joined the team. And we try to always you know, implement the latest ratified extensions. In fact, we, Gary and the team, participate on all these working groups, and we make sure to implement even early, right? The drafts, which is the case for animation pointer, and experimenting even very early. Ranan in the team did some first early implementation around behaviors, and we're, you know, it's pretty active with behavior and complex scene and all this upcoming great interactivity extensions that are coming. I think we're also doing anisotropy pretty soon. Last but not least, of course, WebGPU. That's also something that the team was working early on. Sebastian, Alexis in the team have been working with, you know, I think some people that are in this room for a very long time. It was a great journey. And you know, it's fully supported already today, right? Since the last version, so about a year ago, you know, at the state of the spec, of course. So, and the way it's been implemented is, again, with backward compatibility. So you take your scene and you, just by changing the way the engine is initiated, basically, you can choose which engine to use, WebGL, WebGPU, if it's available. Of course, that's for the existing code, but there are new things, huge new things coming with WebGPU, compute shaders. See here a good example of fluid simulation and rendering, and that's, you know, taking to another level here. You know, you can customize your ocean in some ways. So compute shader are bringing a lot of, opening a lot of possibilities for amazing web experience. And for existing scene, we provide a way to use the render bundle at but that's what we call the snapshot mode. So in some scene, right, where there are there's not a lot of new objects that are added, or for the background, you could use this this mode, and it could be up to 10 times faster. So you have some example there. And if you are in the link, sorry, I'm pointing my screen alone in my room, but you can see some examples of the snapshot rendering, and you'll see like you can switch the playground from WebGL to WebGPU. You can see the increase of performance that is in average about 10 times faster. So it's great, you know, great performance right out of the door. And that is it for me. That is it for Babylon for today. For what's relevant for this audience. There is a big thing coming that is around physics, and that's on. I have to wait for April 20th for this. Thank you all. It was great to be here. I wish I could be here in the room with you all. Thank you. I hope you heard me.
Thomas, I hope you could hear the applause in the room. This was really, really great. In particular, thank you for working on accessibility for 3D. This is so important to bring more people into the fold. And we need to do better, I think, on the web, and especially in the 3D realm. So awesome, awesome work.
Thank you.
So next up, we have Chris Dalton from Rive, and they're going to show us some stuff that's going to blow your mind in the browser with the new Pixel Local Storage extension that they've developed. So please come on up, and let's get you hooked up and ready to go.
What's that? Oh, yeah.
You want to go full screen?
Yeah, let's go full screen. What is that?
If you want slideshow mode.
Oh, on my presentation. Oh, there it is. Yeah, I'll put my slideshow full screen. Okay, so hey everybody, I am from Rive, and for those who don't know, Rive is first and foremost a 2D vector graphics editor. It's web-based. You create vector graphics, animations. First and foremost, it's about animated vector graphics. You can download them and install them in any runtime, one of which is on the web. And so we have been working on a WebGL extension for the past, oh man, I don't want to say, but it's almost been a year, called Pixel Local Storage. And as Ken was saying, it's basically like this idea that every pixel has data associated with it, and you can do whatever you want with that data. And it's all implemented in the Angle backend on every device out there, and it's coming soon to WebGL. So here's an overview of the extension. There are shading language additions. There is this thing called a pixel local angle, and it's like a sampler except it's pixel local. It's an opaque type, and the only difference between it and a sampler from the app perspective is that it doesn't have a coordinate. So you just say pixel local load, pixel local store, and you just get whatever pixel you're sitting on. And so here's an example of how you might set up something to do a blend operation. You would create this opaque type, call the pixel local. In your fragment shader, you load from the frame buffer. We named it frame buffer. You do whatever custom blend you want to it, and then you store to frame buffer. And then you've done a custom blend on the web. The way you do it from the WebGL API side is designed to feel kind of just like using a frame buffer. But instead of saying frame buffer texture 2D, you say frame buffer texture pixel local storage. And you call begin and give you load and store operations so that when this is implemented in tile-based rendering, you can, oh yeah, this is pretty small. All right, that's fine. Let's move on to the demos. Oh yeah, implementation details. Basically, this is pretty much everywhere on the web. So once this launches, you can use it in almost every browser. All right, so I'll exit full screen. And over here, I have a custom built version of Chrome with the Pixel Local Storage extension enabled. And well, yeah, not too many pixels, or not enough pixels. I mean, it looks better at full resolution. So anyway, drawing a bunch of bubbles and you can do any one of the so-called advanced blend equations, and they're all implemented. Just kind of copied the spec on the advanced blend. And so this is an example of how you can do all the blend modes using pixel local storage. Okay, now let's move on over here. I have this is running in Canvas 2D. This is Rive's Canvas 2D renderer. We're going 60 frames a second because the screen is 60 instead of 120. Wait, I probably shouldn't have done that. All right, so running in Canvas 2D, you could draw one, it's kind of okay. But then once we start adding more, oh yeah, this is just so low resolution. But anyway, you can see it starts slowing down. We're down to about 20 frames a second. If I come over here, I have the same thing running on pixel local storage, and I can just keep adding these guys and fill the whole screen. And I wish you could see it in full resolution because it goes from like down to 2 frames a second in Canvas, and it's like 120 on the pixel local storage based vector graphics renderer. So I should clarify that this is a renderer we have built in-house at Rive that uses pixel local storage. And over here I'm drawing some text, and you can zoom in, you can see the quality of the anti-aliasing is just it's very high quality anti-aliasing. We can render all this text directly from points, and we're not caching anything, drawing all from vectors. I can add more sheets of paper, and we're still, okay, well, there we drop down. But all these sheets of paper. On the web, actually, the bottleneck on this text is just how long it takes to upload all of the paths to the GPU to draw this. But it's all being drawn on the GPU, managing all of this anti-aliasing in pixel local storage. And finally, we built a game in-house at Rive on this new render using pixel local storage. So this is all being rendered with pixel local storage. And this guy was created by an artist at Rive. And we have an entire team of designers in-house. We just kind of used the Rive editor to build graphics to put together a game. And it's like just a zombie shoot 'em up game. Yeah, it's yeah. Maybe, oh, I died, yeah. All right, so yeah, maybe come find me after, because it's really not looking as expected on the low resolution screen. But yeah, like a Rive animation is a state machine actually, and so these state machines are all driven by just high level JavaScript. This is in Flutter, so dark code, and then and here we have some variable axis fonts when you blast a zombie. And if you're really good, there's a secret mode, nightmare mode, where you get more zombies. And then if I run this in Canvas 2D, it might do okay with the quarter resolution. We'll see. Yeah. Oh, if I have actually one more minute, I want to show my favorite part of this. I'll die in nightmare mode and show you the normal mode. Or maybe I won't die, we'll see.
You got this.
This is actually, yeah, it's actually kind of fun. Yeah, so we're missing a lot of the view from the lower resolution, which wasn't expected, but okay. So if you thought you were going to see a path rendering demo without the tiger, sorry to disappoint. No?
All right, well, awesome. So just keep in mind, Chris came to us and said, I think we need pixel local storage. I'm like, are you really sure we do? I think every member of the working group thought that. And then they built a whole vector render on top of it, not to diminish Vello, which is also going to be awesome, but I didn't realize that primitive enables this sort of rendering. So another just remarkable technology. Thank you for building this and presenting it. So our last presentation of the day is one that you've all been waiting for. Don't get nervous, Mark. Please welcome Mark Watson from Unity. And Unity has some very exciting, very relevant news to this game developers community. So thank you for coming. Let's get you set up.
Oh, wait, you need to take this out first. I think I have my no. Yeah. Oh. There we go.
I see. So it's
Where's my cursor? Oh, here we go.
Do you want to mirror this instead?
This is fine. Is this? I don't think this is working.
Looks backwards, right?
Yeah.
Is that your notes?
Yeah.
So escape and then drag notes to your desktop. Presenter view.
Yeah.
Down.
Presenter?
Presenter view. Drag down over here.
Drag that to your desktop.
And go back to the screen.
All right, figured it out. So, hey everyone, I'm Mark Watson with Unity, and I just put this deck together today, so sorry that it's a little bit light. It came together at the very last minute, but we have some just exciting news we wanted to share with everybody. So I think this is the first time in any sort of public venue that we're announcing that we're working on WebGPU support. We're targeting an experimental release in a future version of Unity, and we're really excited about the WebGPU support. It really helps make sure the web is competitive with native titles, and pretty much all of the new features that our various graphics teams are working on depend on things like compute shaders. So it really opens up all of the various new features and titles that are built on those features across Unity. Beyond what's named here, so the accelerated graphics particle systems, GPU skinning, that sort of thing, also just a much more efficient runtime for larger games. And a lot of these features we're seeing are rapidly becoming must-have features, and so we're again really sort of excited and betting on WebGPU. And then I also just wanted to bring up that we wouldn't be where we were without support from Google, and especially Ken and his team. Beyond just a lot of back and forth of how to improve WebGPU for games, and especially with the complexity of Unity games, we just have some concrete wins that I wanted to call out. So one of the things was the uniformity analysis escape patch that we were able to work with both Google and the various other members of the WebGPU spec team. That was something that would have been a deal breaker for us, so really great to get that in. Also just working together with increasing various limits that we require. Another thing that we did was look at all of the shaders that we generate from various Unity games and come up with a resource corpus of shaders across the render pipeline to help identify different room for performance improvements. And again, through some of the larger demos that we're building, helping to identify shader compilation optimization needs. And then I know Ken's really upset about this, and I'm upset about it too. We had a really great demo to share with everybody, but because of the last minute nature, I was unable to get permission to share it publicly. But if people want to see it later in private, or if you're another browser vendor, we're happy to share this with you. And again, just looking forward to continue working with the Chrome team and other browser vendors as well to make sure that the performance improvements really enable all of Unity's titles to work on the web. And then I would be remiss if I didn't call out Brendan, who people may have seen him at some of the WebGPU standards meetings. He's really sort of the rock star engineer and his team behind this. I'm just here as the messenger. And so I hope he's watching the live stream somewhere. But if you have really tough technical questions, hopefully you can find him somehow and ask them for him. And then again, if you're a Unity developer and want to learn more, please reach out. And I'm sorry, I wish I could have shown the great demo. Ken saw it, and I can share with some people afterwards as well. Thank you.
All right. Thank you, Mark. Yeah, sure. All right. Thank you, everybody. Oh, have we got a mic? Am I giving feedback? Use this one? Okay. So that's it for the presentations. First of all, I want to thank all the presenters for coming from very, very far away in some cases, and just for sharing your awesome products with us. Second, I actually want to thank Corentin Vallet, who is the tech lead of WebGPU at Google and who has carried his vision forward and brought on so many more people in the development of this new standard. It's going to revolutionize the web. And so, you know, thank you. It's very, very late in Paris time, so probably watching the recording, but thank you in particular. Now, what I'd like to do is, can we ask all the presenters to come up, please? We have a little time for Q&A. We have a live stream chat function so that we can see those questions coming in from the live stream. We'll hands down the microphone to all the presenters, and also actually everybody who's like working on a browser, you are more than invited to come up if you would like to, please do. And we are here to answer your questions about what's going on in browsers and graphics on the web. So please, we've got some mics in the audience, and let's get to it. Can I give this to somebody? Yeah.
And you can run mics for somebody.
Yeah. Please come up to the mics if you have any questions. Love to answer them. I'll check.
So this is a question for the Rive demo, the vector graphics. I hope I'm not mixing that up. You did a good demonstration of pixel local storage, and I understand how that maps to the pixel blending, but how that enables so much better performance for vector graphics went a little over my head. Do you have the 30,000 foot view of what makes that possible with that extension?
Yeah, trying to think what to say here. So we're not sure what we want to say publicly about how we're doing that yet. We're still trying to figure out exactly what we're doing with it. But I'll say that we use pixel local storage. Sorry.
I don't see too many questions coming in from the live stream. Yeah. Yeah, not too many questions from the live stream, I guess. You know, please don't be bashful. Hi.
Sorry, I'm a Unity developer of a Unity question. So my game, I ported to Android and iOS. I'm just curious if I wanted to export it to WebGL. I was always hesitant to do it because I didn't know if it's possible, because my game is about maybe 281 megabytes. So it's maybe a basic question, but do you have to upload the game somewhere on a server before it runs on WebGL?
Yeah, I mean, you would just upload your browser, or you'd upload the build to anywhere that can host your game, and that size should be fine.
But at the same time, yeah, it's going to be a 280, what did you say, 218 or 281 meg download for the end user. And that is a problem. A lot of games are architected that they've got all the data up front and then they're ready to go. But for the web, you really want instant load, show something, stream everything in the background, reduced art asset size at the beginning, stream down the high resolution textures and data. Do you want to talk more about that?
No, I mean, no, just continue what he said. There's always the time to the first draw and time to first interaction, and trying to figure out how you can. People have different expectations when they're on the web than clicking download in the Play Store and waiting for all the assets to be downloaded. So just figuring out how to do that and use, there's lots of Unity tools out there to help you, including the addressables package and other things like that. Come talk to that guy in the red shirt. He's the web product manager.
Who was first?
So how's Firefox WebGPU doing, and how can we help you? What would you like from the community to help?
How can you help?
Help with Firefox?
What an interesting question. We're working on it. So I think we actually put up some of the last few blockers today to let us turn it on by default in Nightly Firefox. So that should be on Windows and Linux. Windows initially, I think, is what we're doing. So like very shortly, Nightly will just start to be able to do WebGPU stuff. What we want from the community is, if it's not working in Firefox, tell us what's not working and we will fix it. Right now, we're definitely in like the triage and prioritization stage. We're a little bit behind the spec. The spec's done a lot of evolution, and we have not entirely caught up with it. So we're working on it, but if it doesn't work yet, it's not on purpose. But the more you tell us about like what doesn't work for you, the more we can get that working, and then focus on the like making sure like negative floating point nans or something work exactly properly according to spec. Like we can do that later, but if we don't have prioritization, we would love to get your thing working is the main thing. So just come talk to us.
If you don't mind, I'll add one thing to that. So I'm on the Chrome team, not the Mozilla team. I won't speak to the work that they're doing, but recently we did some experiments to see what the delta was between what we were doing in Chrome and what we were doing and what they were able to do in Mozilla. And I was pleasantly surprised by how little we had to patch up to get things up and running. They're making great progress. It is not that far behind Chrome, and they're catching up quickly.
It's kind of the classic graphics thing where it's like you spend a really, really, really long time with a black screen, and then you get it to turn a color, and then you get like a spinning cube, and then like later that afternoon, after the spinning cube works, like the rest of the scene works, right? It's like that kind of thing, like the definition of like request adapter change. So you can't get that, but as soon as that works, everything else kind of falls into place. But just let us know.
Yep, I'm also on the Chrome team. I also want to add one more thing, which is it's a huge help if you try your stuff on Firefox, because you might find Chrome bugs. If you find something that works on your Chrome and it doesn't work on Firefox, it doesn't mean it's a Firefox bug. So please test your stuff and let us know, and somebody will fix something.
Bravo. If you don't mind, I'll take a remote question. We actually have one. And XR Dev, I don't know how to pronounce his name, Logar asks, are there any upcoming WebGL or WebXR focused hackathons that are remote friendly? You know of any WebXR remote hackathons?
I am the WebXR guy. Huh? Unfortunately, I don't have a good answer for you on that. I have been very, very heads down in WebGPU land, and so I don't have great answers for you in terms of WebXR right now, and I apologize for that. There is a fairly active WebXR Discord community, and so I would highly suggest seeking them out and asking there, because you will definitely get a good answer.
All right, sounds great. Actually, I would also encourage you to look at like is it pronounced Ludlum Dare? Ludlum Dare, okay, game jams. Plenty of web developers attend these and do web-based games, so you can hone your WebGL skills there without having to try to find a WebGL-focused hackathon. So Teo, please, I see you're burning.
I'm just wondering if anybody is using anything like Copilot or any other AI tools to develop these very low-level tools, whether anything like Copilot is up to the speed that was of any help to you guys.
Actually, our architect is using that Copilot. Come on. Come on, come on. He's a doctor and a PhD, and he's our architect, so very experienced guy and using Copilot, let's say.
Yeah, Copilot is quite good. When you are writing some code, if it is quite basic, it can complete the code immediately. But if the context is a bit complicated, then it might not finish the job. It's difficult. I think with the evolution of the Copilot, it will becomes better and better.
So you believe in that?
I'm not quite believing it. because because we are programmer. If a Copilot is too good, maybe we will lost our job.
Okay.
So one small caveat that I'll put on that is that Copilot and all of these other AI-based tools based on large language models, that means that they need a large amount of language to operate on. And so therefore, at the moment, there is a huge corpus of GLSL code and OpenGL code and WebGL code on the web, largely in part to the fantastic community that we've had behind it. And so it can frequently produce reasonable looking results for those. You're not going to get that with WebGPU right now because there's just not nearly enough volume of content out there to supply those language models with a statistically relevant thing. So right now, if you ask it to write some WGL for you, it will give you GLSL. And if you say, no, that's not right, it says, oh, here's some HLSL for you with enable GL model like 320 at the top. So they're good as long as you understand the limitations behind it. And I'm sure that WebGL will develop, or WebGPU will develop the same volume of examples in the near future.
This question's for the Chrome team, probably. So my name's Philip. I work for Arco, which is a collaborative CAD startup. And we do these, we want to create regression tests. We basically want to run Chrome in a headless way on a machine without a GPU for regression testing purposes. So I'm wondering, like, is WebGL 2 supported with, if a machine doesn't have a GPU? Is WebGPU supported on a machine that doesn't have a GPU, despite the name?
Okay, I can start, and then I'd like to hand off the question to teammates who are focused more on the WebGPU side. So yes, Chrome uses Swift Shader for its software rendering and does support WebGL 2, absolutely. So you can get that. Our team does a lot of this sort of regression testing, and actually we're focused only on the GPU case because that's what end users have in their hands, in their laptops, on their desktops, et cetera. Every device out there pretty much has a GPU now, which is an amazing turnaround of the industry if you really think about it for the last, I don't know, 20 years. So we do run Chrome not quite headless in our CI systems. I'm sure that Kelsey could talk about Firefox and CI systems as well. But we'll welcome, and you can use Puppeteer for this, for example, one framework. We use something called telemetry, which is it's a Chrome DevTools protocol specific thing, and it drives the browser very directly. But anyway, we're happy to talk more about this, and we would love to improve the fundamentals for testing this stuff in the field as well. Other folks that want to talk about WebGPU support?
Yeah, I can say, so for WebGPU, we in principle have Swift Shader, like software support, as a backend, but right now I believe we are not shipping it. We are mostly not shipping our Vulkan backend yet, and we use Swift Shader's Vulkan implementation. So I think we're not shipping yet with Swift Shader, but the code exists, and I think you can turn it on with a flag. So for testing purposes, it may work, depending on the platform exactly. I do not know whether it works in headless right now. All this stuff is like not quite done yet, but we're getting very close. As for headless testing, I heard recently that there's a lot of work going on for like general headless testing with the browser. So I think that there will be a lot of good news in terms of like using Chrome for that kind of for like regression testing in the near future.
What's the off-screen canvas support looking like for WebGPU at launch, and maybe WebXR support for off-screen canvas too?
So WebXR or WebGPU off-screen canvas is fairly well supported, I believe. Like I don't think that we have any major issues with it. The biggest issue that we had for a while was there was a frame pacing issue, and I believe that that's been resolved. Otherwise, it just kind of does the right thing. It's also important to note that if you want to do operations with WebGPU and you don't need a canvas, you don't have to create an off-screen canvas, unlike WebGL, because we've separated the canvas and the device APIs to make that kind of thing easier. So depending on what your use case is. For WebXR, my recollection is that it has worked well for a while. You just need anything that has a WebGL context, and then we actually produce a separate swap chain of buffers that's not reliant on the canvas.
There's one more thing, which is the request animation frame for WebXR. I don't think that's available, or is it not?
So request animation frame for WebXR is specifically a property of the session, not the canvas itself.
Okay.
Because the headsets usually run at a different rate than the screen that you've got connected if you have an external monitor.
Cool.
Yeah, it should just work.
Awesome.
Hi. I'm just wondering, I guess, if there's any work going into some of like the like debugging, like graphics debugging tools on browsers. Right now I'm using like Spectre.js, and it's pretty good, but you know, it's not RenderDoc or anything like that. So yeah, I'm just kind of wondering if there's anything going on around that.
Greg, do you want to? Yeah.
Get him a microphone.
Last October, Google gave us 3 weeks to do some explorations, and we kind of prototyped a WebGPU debugger. It's very alpha. Hopefully we'll get more time to flesh it out. It's up on GitHub, so if you want to help flesh it out, you can, but it is very alpha at the moment. But yeah, hopefully we can get that somewhere pretty cool. Also, the WGSL debugger, James Price is on the Tint team, and he managed to make a software WGSL runtime and debugger, and we hope we can integrate those things because it was very amazing. Like it could step through every part of your shader and show you every variable, and even find like races and lots of stuff like that. So yeah, we would really like to make that happen at the moment, but yeah, I don't know what the plans are, but there is some effort there.
There's a lot of like general investment in that area, but maybe not as much commitment as you'd be hoping for. But there's a lot of general investment, and out of general investment comes a lot of like really cool things. So I think this is like a stay tuned and watch the cool things come out thing. I will mention though that the WebGPU debugger, I believe that's the second repo on the github.com/WebGPU.org next to the WebGPU samples. So those are the two things up there. So that's definitely worth checking out, and that's where it lives. Thanks.
Thanks a lot. And also, we'll really appreciate your feedback. Like, please join the Matrix chat room. You can reach many of us there, and we'd love to know what you want to see from these kinds of tools. We don't want to reinvent the wheel, and doing it in the web browser may not even be feasible. You know, using super low-level primitives that RenderDoc uses in order to capture its traces, you know, replay them efficiently, etc. We don't know. It's already a hard problem replaying the traces that are being captured by this WebGPU debugger. So we want to know what you want to see. We have some ideas about, okay, how could we integrate a WebGPU debugger with RenderDocs to make it a lot easier for you to use that tool with your WebGPU application for example, but it's all pretty early. As the WebGL person, I want to say that I think we could have made more investments in the tooling earlier on, and we definitely want to do that for WebGPU. So now is the time to please, start telling us the use cases that you want to see. And we're trying to do this in cross-browser manners. So the WebGPU debugger is like injectable in your app, and it works on every browser already. And if we integrate into DevTools, at least my thought is we would do it as a DevTools extension, not built into the browser, so that it has the best portability and reach, and the community can help extend it.
Yeah, sounds good. Yeah, thanks.
I just wanted to mention also that before I knew they were working on one, I started working on a WebGPU and WebGL replay tool. So I have a demo over here if you want to see it later.
Looks like we have another remote question. Let's see. Okay, the same developer, XR Devlog, asks, what is something that folks here on the stage are looking most forward to after WebGPU ships? I think it would be good to get everybody's opinion on this. So. Please pass down the mics.
Well, in terms of WebGPU features that I want to see, I think there's three things. That one of them is bindless, which I think everybody wants. The second thing that I want to see is subgroup support in compute shaders, and then subgroup support will also unlock some of the performance in AI type workloads. That's not what I do, but like it will speed up the Vello rendering a lot, and it'll also speed up a lot of other workloads. And the third thing is something super technical. It's device scope barriers, which is just something that like CUDA has that WebGPU doesn't have for technical reasons, and I'd love to see that in there as well.
So for us at Vectary, basically, like what we would like first and foremost is like to have like maybe like a broader adoption, like in the types of tools that we can just tap on. But since I heard somewhere that there is actually a possibility to have ray tracing as well, maybe actually we'll not need it so early. But yeah, mostly it's like just to try things that that we can get our hands on, just to get more performance on the types of effects that people are requesting from PBR type of rendering for us.
So for Cocos, I think the fact that WebGPU is being a modern graphics API is just enough attracting for us, because our rendering backend have been merging Vulkan, Metal, and WebGL together, and WebGL is the only one who is a legacy API, or we can say that maybe. And we really hope that the WebGPU support can unify all the up-level infrastructure for us. That will save a lot of work, and that will release a lot of power for developers, like the parallel rendering, computer shading, and all sort of GPU-driven pipeline, all sort of cool things. Yeah.
I wrote a GLSL compiler, so don't ask me.
Sorry.
I think just native quality games. I think there's a lot of learnings that can move in both directions. There's similar problems for building Android games over the large types of Android devices as building web games. And with new technologies like WebGPU, there's starting to be more parity. And so I think, yeah, again, taking learnings from each other, how can we reduce install sizes across different types of games, and you're targeting different platforms and streaming content in, and making sure that games run as optimally as possible across wide ranges of hardware types and operating systems and browsers.
I don't know how to build on what's already been said, but I'm looking forward to the partnerships that we have with so many companies and so many groups and individuals, and seeing what comes to fruition with WebGPU. We want to hear the features that you want to see, the pain points that you've been having during the development process, improve the the API, the implementations in browsers, and the tooling to help you write awesome graphical and compute apps on the web.
What am I looking forward to after we ship WebGPU? A break. But seriously, one of the things that I loved about when we shipped WebGL was that a lot of the people who were building the API at that point expected like, hey, we're building something cool for games on the web. And there are absolutely awesome WebGL games on the web. We've seen some here tonight. But some of the most interesting use cases that came out of it were things that we never planned and things that never really would have made sense until we brought that to the web. So what I'm looking forward to is the thing that surprises me, where we say, well, now that we've gone to this next step, we've brought compute, we've brought all these modern APIs to the web. What's the thing that didn't make sense before and now it does? And I'm hoping that someone watching this stream or somebody in this room is going to be the one to show it to us.
I have to follow that, huh? I'm looking forward to mesh shaders. Anyone like mesh shaders? Pretty cool, huh?
The other thing and this is like very technical stuff. I really want to get our WebGPU in workers like multi-threading like thing put together. Like that's been like one of the big things that was part of this current gen of graphics APIs is being able to do things on different threads, unleashing like the whole breadth of the CPU. And like a lot of the gains come from that. And that's one promise we haven't been able to deliver on yet, but we're super excited to. We're just very sad to put it like outside of scope for 1.0. But we're so excited to pick it back up, and we're so excited to deliver something really cool for you.
Yeah, that's a really big deal. Another one, not to overrepresent Google, but another one that we're really excited about is WebGPU in native. As you already saw, like with Rafe's demo, WebGPU in native is a pretty big deal. It gives you a lot of portability. It lets you do native, like it lets you write your application and use it on and run it on a lot of hardware pretty effortlessly. We really want to shore up like the ecosystem and the APIs in native so that WebGPU really becomes more of a first-class thing. Right now, like it's like a stable 1.0 for the native situation is not going to come until a little bit after like web stuff is shipped. But it's already like very much out there. People are using the native API like in Scripting to target the web as well as other platforms. So like, and of course, WGPU also can target the web as well as native platforms. That is going to be really, really useful, I think. And in the same way that OpenGL was, being able to take OpenGL and bring it to the web, having WebGPU in native is going to provide a lot of that same benefit. So I'm really excited about that personally.
I just think it'd be cool if somebody else could implement pixel local storage in WebGPU.
All right, so we're over time, so I think we should call it there. Thank you, everybody, for coming. Thank you, all presenters, everybody who participated in this. Thank you, support staff, for an awesome event. We have the space till 9:30, so please come, eat the food, drink the drink, and chat. It's great to see you all, and we'll see you again soon.
I have a quick comical last question. Where are the WebGPU stickers at?
No, Greg graciously made these and paid for them out of pocket. We'll bring them to the next meetup, and ping us on Matrix chat if you want to meet up earlier and get some. All right, thanks.